In this video, I'm going to go over the rules of exponents so that you can understand why they all make sense. Here are the rules. There's 8 different rules, and we'll cover each one at a time. The first one is x to the a times x to the b. That's going to equal x to the a plus b. Let's look at an example why that's the case. So x squared times x cubed would become x times x times x times x times x. I'm writing out how many individual x's that I have over here compared to this side. So altogether, how many x's are being multiplied by each other? Well, there's 2 plus another 3. That's why it's going to become x to the 2 plus 3, which equals x to the power of 5. That's why x to the a times x to the b equals x to the a plus b, and that's why you're going to add your exponents in that case. The next rule is x to the a divided by x to the b. That's going to equal x to the a minus b. Here the example is x to the 5 divided by x to the power of 3. That's going to be 5 x's on the top being multiplied by each other, 3 on the bottom. We can cancel out 3 in the bottom with 3 in the top, and we end up with just 2 x's in the top. So it's going to be x to the 5 minus 3, which is x to the power of 2. That means I have 2 more x's in the top compared to the bottom. So x to the a divided by x to the b equals x to the a minus b. The next rule is x to the a raised to the power of b. That equals x to the a times b. Here the example is x squared to the power of 3 is going to be x times x, that's the x squared. Raising something to the power of 3 means we multiply it by itself 3 times. So there's 3 groups of 2 x's being multiplied by each other. 3 times 2 is 6. That's going to be the same as 2 times 3. So x to the 2 times 3 equals x to the power of 6. X to the a to the power of b equals x to the a times b. Next is x times y to the power of a. That's going to equal x to the a times y to the a. The example is x times y squared. That's going to be x times y times x times y. I can just rearrange that to put the x's next to each other and the y's next to each other. X times y times y. That equals x squared times y squared. So x times y all to the power of a equals x to the a times y to the a. Each of the factors inside the parentheses individually gets raised to the power of a. Next, x divided by y to the power of a equals x to the a divided by y to the a. Here we have x over y squared. That means x over y times x over y, which is x times x divided by y times y, which is x squared over y squared. So x over y all to the power of a equals x to the a divided by y to the a. Each part inside here gets individually raised to the power of a. It's kind of similar to this rule in that sense. Next, we have a negative exponent. X to the negative a equals 1 over x to the a. An example that can help us make sense of that is x to the power of 3 divided by x to the power of 5. That's 3 x's being multiplied by each other on the top. There's 5 on the bottom. And we could cancel out 3 on the top with 3 on the bottom. So we get 1 over x squared. So that's 1 over x squared. But x to the 3 over x to the 5, we could think of it in another way by applying this rule, x to the a divided by x to the b equals x to the a minus b. So if we use that rule, x to the 3 over x to the 5 equals x to the 3 minus 5, and 3 minus 5 is negative 2. So we'd end up with x to the negative 2. Just to think about this another way, here where we had x squared, that meant that there were 2 more x's in the top than the bottom. Here it's the opposite of that. X to the negative 2 means there's 2 more in the bottom than there are in the top. So x to the negative a equals 1 over x to the a. X to the negative 2 equals 1 over x squared. Next is x to the power of 0 equals 1 if x does not equal 0. We can think about that this way. We can say 1 is equal to anything divided by itself. X squared divided by x squared is going to equal 1 as long as we're not dividing by 0. So x can't be 0. Well, if we use this rule again here, where we're subtracting the exponents when there's a division with the same base, then 1 is equal to x to the 2 over x to the 2, which equals x to the 2 minus 2. That would be x to the power of 0. There are no more x's in the top than there are in the bottom. There's the same amount in the top as in the bottom. So x to the 0 would equal 1 because it just means that there's the same amount in the top as in the bottom. So x to the 0 will equal 1. That's as long as it's not 0 raised to the power of 0. The last rule is x to the a over b, and this is called a rational exponent when you have a fraction as an exponent. So x to the a over x to the b equals the b root of x to the power of a, or we could say it's the b root of x all raised to the power of a. Here's an example that shows why that's the case. So let's say we have x to the 2 over 3 is going to be equal to the third root of x squared. That's using these two expressions and saying that they're equal to each other. So how can I show that that's going to be true? Let's raise each side to the power of 3. So this being raised to the 3, this being raised to the power of 3, we'd get this. X to the 2 over 3 raised to the power of 3 means that if we apply this rule here, x to the a to the power of b equals x to the a times b, we're going to multiply the exponents. So 2/3 times 3 means that the 3's cancel out. And we'd be left with x to the power of 2. On this side, the cube root of x squared raised to the power of 3, well, that would mean that raising something to the power of 3 and taking the cube root, these are inverse operations. They cancel each other out. So we'd just be left with this x squared here. So this became x squared, this became x squared, therefore x squared equals x squared. So both of these were equal to each other originally. It's going to work out so that this actually works too. So if we have the b root of x all raised to the power of a, that would be the same thing as the b root of x to the power of a. Here's an example with numbers that shows that's the case. Let's say we have 8 to the 2/3. That'd be equal to the third root of 8 squared. That's using this part here first. Well, that's going to be the third root of 8 squared is 64. The third root of 64, what times itself? 3 times is 64. That would be 4. So this equals 4. Looking at this expression here and rewriting 8 to the 2 over 3 this way, I get the third root of 8 raised to the power of 2. The third root of 8 is 2, and 2 to the power of 2 equals 4. So in both cases, we'd end up with the same thing. So there you go. Those are the main rules of exponents that often get used, and hopefully that helps you make sense of why they all work. Lastly, I'll put a link in the description for where you can download this document from the eMath Academy website and use it for studying. If this was helpful, don't forget to like and subscribe.